Good day, everyone. We are here to present to you our capstone project, which is Application of Tree in Real Life. I am Angela Kate Bundalian and my partner Alexis Shane Lineses. She will discuss her genealogy tree.
As we learn in this course, graph theory is a useful tool for creating a visual representation of objects and relationships. One type of graph that we will be focusing on in this video is the tree. Let us now show you an application of trees in real life. A tree is a discrete structure that illustrates the organizational structures between specific elements or nodes. Trees can be used to design circuits, analyze complex circuits, and deal with the computer networks. They can also be used to study algorithms and design them in flowcharts. So this is my genealogy tree. These are my grandparents, Lourdes Eranjo and Romeo Eranjo. They have 6 children: Rene Eranjo, Jerry, Malu, Melba, Maylene, and Romeo Eranjo Jr. There are 4 members in my family: my father, Randy Leneses, and my brother, Rich Boris Leneses.
Let's take the given arithmetic expression shown as an example. To do this, we first have to divide the expression into two while identifying which operator is the root node. In this case, it is addition. It might be tricky as you might be asking, why not the subtraction before if it is not subtraction, as it will operate among all of its children. Thus, it will subtract all the right term from the left term when we only want to subtract it only. Thus, we have to be careful in dividing the expression. Next step is to construct two nodes connected to the operator. Represent the operands as lymph node. We take an 8 and represent it as a lymph node. Represent the operators as internal nodes while dividing the sub-expression into two sub. This sub-expression will be divided into two, making an addition as the root node of the subtree or the internal node that has chosen. We will be dividing the sub-expression into two, making multiplication and division. As the internal nodes, we will take also 3 and 6 as the lymph node under multiplication, while we will be taking 3 division as a lymph node also. Dividing again this sub-expression, we will have the subtraction as internal node and 5 and 2 as lymph node. We will again repeat this process on the right side of the expression until we completed representing the whole expression in a tree structure. Now, we have here the resulting tree we have constructed using the arithmetic expression. As it has been organized in this structure, this makes it easier to solve for its answer to start solving the bottommost subtrees. Perform arithmetic operations among the operands, replace the parent node with your answer and your way up in solving the tree. Solving for 5 minus 2, it will be 3. 3 times 6, it will be 18. Then 3 divided by 3 is 1. Is 1, while 6 minus 3 is 3. Let's work our way up until we get the final answer. The final answer for this arithmetic expression is 4. Here are the steps in traversing a tree in pre-order. First is to visit the node, second is traverse the left subtree, and lastly, traverse the right subtree. We will use the binary tree we have constructed a while ago. First, we visit the root node, then print its value, which is plus. Then we move to the left subtree, visit it, and print its value. We move to the left, visit the node, and print its value until we reach the bottommost node, which is 3. Since there's no children, we pretend that we've performed moving to its left and right We then go back, then perform traversal to the right subtree. Then revisit and print its value, and again go back. Follow the step and continue the pattern until we visit all nodes. Here's the final answer in pre-order. Next is traversing a tree in order. We first traverse to the left subtree, visit the node and traverse to the right subtree. We start with the root node and traverse to the left subtree until we reach the bottommost lymph node, which is 3. We then pretend with reverse to left subtree going back. We visit 3, prints its value, the first one, and imagine our right subtree, then go to upper node, which is the multiply operator. Visit it, visit it, print its value, and move to its right. Watch as I repeat the process until we visited all nodes. Here are the results. Ulit. Ulit nga. Next is traversing a tree in order. We traverse to the left subtree, visit the node, and traverse to the right subtree. We start with the root node and traverse to the left subtree until we reach the bottommost lymph node, which is 3. We, we then pretend with reverse to left subtree going back. We visit 3, prints its value, the first one, and imagine our right subtree, then go to upper node, which is the multiply operator. Visit it, print its value, and move to its right and move to its right. Here's the answer in order. Lastly, we have the post order. In traversing a tree, the steps will be first to press the left subtree, the first right subtree, and lastly visit the node. We will follow these steps and that will make 3 as the first output. We then go back to the parent node, move right, and visit the lymph node 6 as it has no children. We will follow this pattern. The last printed value should be the root node. Should be the root node. Here's the final answer in post order. And that will be all for our discussion of applications of trees.